Malaysia looks like a single country on the map, but in reality, it doesn't function like one. On the west coast, you have Kuala Lumpur, Port Klang, and most of the country's industry packed into a relatively small area. This side handles the majority of Malaysia's trade, manufacturing, and economic activity. In fact, the Klang Valley alone contributes more than 30% of Malaysia's GDP, making it the economic engine of the entire country. But move to the east coast and things change quickly. Fewer industries, less infrastructure, slower development, and most importantly, weak connections to the rest of the country. States like Kelantan, Terengganu, and Pahang have historically lagged behind in industrial output and logistics connectivity compared to the West. Now here's the problem. If you want to move goods from the east coast to the west, you don't just drive straight across, you go around, through longer routes, through roads that were never designed for heavy freight at this scale. Much of the existing road network, including Federal Route 2 and older mountain passes, struggles with heavy truck volumes and terrain constraints. And that adds time, cost, and limits growth. In some cases, freight movement between coasts can take over 12 to 15 hours by road, depending on conditions. So Malaysia made a decision. Build a $16 billion railway that cuts directly across the country, from Port Klang on the west coast all the way to the east. A railway stretching over 660 kilometers, or about 410 miles, crossing mountains, dense rainforest, and some of the hardest terrain in the region. And China is helping build it. But how exactly is this railway supposed to fix a problem that has existed for decades? And why is it being built at this scale? The project is called the East Coast Rail Link, or ECRL. At its core, it's a long-distance railway that cuts across peninsular Malaysia, connecting the country's main economic hub on the west coast to the less developed east. The full route runs for about 665 kilometers, or about 413 miles. It starts near Port Klang, Malaysia's largest port, which handles over 13 million TEUs annually as of recent data, making it one of the busiest ports in Southeast Asia. From there, it moves inland toward the Kuala Lumpur region. From there, it pushes east, crossing the Central Mountain Range before reaching Kuantan on the east coast, and eventually extending further north toward Kota Bharu, near the Thailand border. So instead of going around the peninsula, freight and passengers will be able to move directly across it. Now, in terms of design, this is not a slow, conventional railway. It's built using standard gauge track, which is 1,435 millimeters wide, the same standard used in high-speed and heavy freight rail systems globally. This allows higher speeds, better stability, and heavier axle loads compared to Malaysia's older meter gauge network. Passenger trains are expected to reach speeds of up to around 160 kilometers per hour, or about 100 miles per hour, while freight trains will carry large volumes of cargo across long distances, with projected capacity in the millions of tons annually once fully operational. But the railway itself is only part of the plan. Along the route, more than 20 stations are planned, including major hubs and smaller regional stops. In addition, multiple cargo terminals, inland ports, and logistics hubs are being developed. These are meant to connect industries directly to the railway, reducing the need for long truck journeys and making the entire system more efficient. Some of these logistics hubs are strategically placed near industrial zones to attract manufacturing and distribution businesses over time. On paper, the route looks simple. Draw a line from the west coast to the east, lay down track, and connect the country. But once construction starts, the reality looks very different. Right through the center of peninsular Malaysia sits the Titiwangsa Range. It's not just a series of hills. It's a continuous mountain backbone stretching over 480 kilometers, or about 298 miles, covered in dense tropical rainforest, with steep slopes, unstable ground in some areas, and heavy rainfall throughout the year. This is where most of the difficulty comes from. To get the railway across this region, engineers cannot rely on straight ground-level track. They have to cut through mountains, cross valleys, and avoid areas where the soil cannot support heavy infrastructure. That means tunnels and bridges, a lot of them. The project includes over 40 tunnels in total, with a combined length of more than 50 kilometers or about 31 miles. One of the longest tunnels alone stretches over 16 kilometers or about 10 miles, making it one of the longest railway tunnels in Southeast Asia. These tunnels have to pass through hard rock in some sections and softer, more unstable ground in others, which requires different construction methods along the same route, including tunnel boring machines and drill and blast techniques. At the same time, large sections of the railway run on elevated viaducts. In fact, roughly 30% to 40% of the route involves bridges and elevated structures. These structures lift the track above rivers, flood-prone land, and uneven terrain, keeping the line stable and operational even during extreme weather. And weather is a major factor here. Malaysia receives annual rainfall exceeding 2,500 millimeters in many regions, especially during monsoon seasons. That creates risks like landslides, flooding, and soil movement. Engineers have to design drainage systems, slope protection, retaining walls, and deep foundation systems that can handle these conditions over the long term. Then there's the issue of access. Much of the route passes through remote areas with limited existing infrastructure. Before construction can even begin in some sections, temporary roads, worker camps, and supply routes have to be built just to move equipment into place. So this is not just a railway project, it's a full-scale infrastructure operation happening across hundreds of kilometers at the same time. And that leads to another question. Why bring in China to do it? And what exactly is China's role in this project? To build something at this scale, Malaysia needed more than just a construction plan. It needed financing, technical capacity, and a contractor that could handle hundreds of kilometers of work at the same time. This is where China comes in. The main contractor for the project is China Communications Construction Company, one of the largest construction companies in the world, ranked among the top global infrastructure firms by revenue. This is the same company involved in ports, railways, highways, and large infrastructure projects across Asia, Africa, and Europe, including projects under the Belt and Road Initiative. On the financing side, a significant portion of the funding comes from Chinese-backed loans, primarily through Export-Import Bank of China, which has financed multiple large-scale infrastructure projects globally. So this is not just a local project with foreign contractors, it's a joint setup where China provides both the construction capability and a large share of the financing. But here's the important point. Malaysia has been trying to improve connectivity between its east and west coasts for decades, with proposals for cross-peninsula rail links dating back to the early 2000s. China's involvement made it possible to move forward at this scale. At the same time, this kind of arrangement raises obvious questions. When a project is funded and built with strong foreign involvement, especially at this cost level, people start asking about debt, control, and long-term impact. And that's exactly what happened with the ECRL. Because before construction could fully move forward, the entire project was paused and then renegotiated. From the beginning, the scale of the ECRL came with a high price tag. The original cost was estimated at around 65 billion Malaysian ringgit, which is roughly 16 billion US dollars at the time. For a country the size of Malaysia, that is a major financial commitment, equivalent to several percentage points of its GDP. And for a while, construction moved forward. But then, in 2018, everything changed. A new government came into power, and one of its first decisions was to review large infrastructure projects, including the ECRL. The concern was simple. Was this project too expensive for what it delivers? There were questions about financing terms, total debt, interest rates, and whether the expected economic return would justify the cost. At that point, construction was suspended. This is where things could have ended. Large projects like this don't always come back once they are paused, especially when political priorities shift. But instead of canceling it completely, Malaysia chose a different approach. They renegotiated. The government went back to the contractor and reworked the terms of the project. The total cost was reduced to around 44 billion ringgit, bringing it closer to 11 billion US dollars. That's a reduction of roughly 1/3 of the original cost. At the same time, parts of the route were adjusted to improve efficiency and reduce construction complexity. After that, construction resumed in 2019, and this entire phase highlights something important about megaprojects. They don't just depend on engineering, they depend on politics, financing, and long-term economic expectations. As of 2026, construction is active across multiple sections of the route at the same time. Major civil works are already well underway. One of the most critical parts of the project is the tunnel network through the Titiwangsa Range. These tunnels take the longest to complete because they involve continuous excavation, ground stabilization, and lining. Progress here is steady, but it moves at a controlled pace due to safety and geological conditions. At the same time, in other sections where the terrain is less complex, construction is moving faster. You have visible structures already taking shape, including bridge spans, elevated track segments, and station foundations. The workforce is a mix of local Malaysian workers and Chinese engineers and specialists, with thousands of workers deployed across different sections of the project. And that matters at this scale. When you're building over 600 kilometers of railway, working on multiple fronts is the only way to stay within the planned timeline. Speaking of timeline, the current target for completion is around 2026 to 2027, with the possibility of phased openings for certain sections before the entire line is fully operational. That means parts of the railway could start operating while construction continues elsewhere. Now, to understand where the ECRL fits in globally, you have to look at one of the most important trade routes on Earth. The Strait of Malacca handles a massive share of global trade. Every year, more than 90,000 vessels pass through this narrow stretch of water, carrying oil, raw materials, and manufactured goods between Asia, the Middle East, and Europe. Malaysia's west coast sits directly on this route. That's one of the main reasons why ports like Port Klang became so dominant. But here's where the ECRL changes the equation. Instead of relying entirely on sea routes, Malaysia can move part of that cargo across land. For example, a container arriving on the west coast doesn't always have to continue its journey by sea. It can be transferred onto rail, cross the country, and reach the east coast faster than a ship going around the peninsula, which can take several extra hours depending on congestion. This creates what's often called a land bridge. Now, it's important to be clear here. This railway is not replacing the Strait of Malacca. The volume of global shipping is far too large for that. Moving goods by sea will always be cheaper for long distances. The advantage comes in specific cases: time-sensitive cargo, regional trade within Southeast Asia, situations where ports are congested. In these cases, even saving a few hours or a day can make a difference. It also gives Malaysia more flexibility. Instead of relying on a single route, the country now has an alternative path for moving goods. But the bigger question goes beyond Malaysia. So let me ask you this: what does it mean when projects of this scale are being built with strong Chinese financing and construction? Is this simply the fastest way for countries to build infrastructure they've needed for decades? Or does it slowly shift influence over key transport networks in the region? And if this model works in Malaysia, how many more countries will follow the same path? Because this is not the only railway China is involved in, and it won't be the last. Let us know your thoughts in the comments below.